Hey guys, in today's video I'll be talking about Nitrosyl perchlorate, a powerful oxidant that's the anhydride of nitrous and perchloric acids. In the description of the properties of this substance, it's indicated that pinene explodes sharply, acetone and ethanol ignite, then explode. Ether evolves gas, then explodes after a few seconds delay. In this video, we'll mix these substances with Nitrosyl perchlorate to observe these reactions firsthand. The synthesis of Nitrosyl perchlorate is quite simple. You just need to bubble a mixture of nitrogen oxides, nitric oxide and nitrogen dioxide into a solution of perchloric acid. Initially, I used commercially available 50% perchloric acid and produced the nitrogen oxides by dropping nitric acid onto solid sodium nitrite. When passing the nitrogen oxide mixture through perchloric acid at this concentration, the solution turned blue, indicative of nitrous acid, but no Nitrosyl perchlorate precipitate formed. I stopped the reaction and replaced the 50% perchloric acid with a more concentrated solution, close to 70%. After some time, a noticeable amount of a white substance accumulated at the bottom of a beaker. I filtered out the precipitate using a glass filter without washing it, since this compound reacts vigorously with most solvents and water. Due to the lack of proper washing, the substance didn't dry fully, but this won't affect its chemical reactivity. When heated, Nitrosyl perchlorate melts and then decomposes into nitrogen dioxide, chlorine and oxygen. If you throw a piece of paper into molten Nitrosyl perchlorate, it will vaporize instantly. Like other nitrosyl salts, Nitrosyl perchlorate hydrolyzes immediately upon contact with water. Since it's a mixed anhydride of nitrous and perchloric acids, adding water converts it into these two acids. The blue color in the solution is due to the formation of nitrous acid. Now let's move on to the reactions highlighted in a handbook of reactive chemical hazards. First up is the reaction with ethanol. According to the book, we'll first see ignition, followed by an explosion. However, in this experiment, I only observed an explosion with no sign of combustion. Let's review that in slow motion. So I would say here first an explosion occurs and then combustion. Now let's check the reaction with acetone. Upon contact with acetone, the mixture turned yellow and started bubbling, definitely a bad sign. The reaction with acetone was much more intense. Now let's see how diethyl ether reacts. It's interesting, the book didn't mention anything about a reaction with anhydrous hydrazine, so let's give it a try. It doesn't look impressive, but with phenylhydrazine it will be more spectacular. If you see that something reacts violently with aniline, it reacts tenfold with phenylhydrazine. The reaction with pinene was also indicated here, so I added a reaction with turpentine to this video. Up until now, all the reactions were between solid nitrosyl perchlorate and organic liquids, but in this case both reactants are solids. Since one of the reactants contains boron, this solid-solid reaction produces a green flash. So guys, I hope you enjoyed this video. Hopefully you're now even more convinced of the importance of thoroughly studying chemical properties before working with chemicals. And of course, special thanks to my patrons, whose support makes it possible for me to continue producing videos on chemical reactions. If you'd like to join them, the link to my Patreon is in the description. See you in the next video.